Welcome everybody. I hope you are gonna enjoy this talk because it's something that's very close to my heart and what I really enjoy talking about. The headline is about the new eIDAS 2.0 and the new digital wallet. And I'm saying it's not trustworthy. I'm going to show you what I say it's not trustworthy. It's not secure enough. I think that's the main agenda. But the most focus is in how to make it trustworthy, because that is what we should be doing. And what is especially the key is that they are trying to remedy details of a regulation where they should be going upstream and solving the core. That's what I'm going to talk to you about. Okay, so let's get started here. First of all, I talked about a year ago here about trustworthy anonymity and how we could solve sort of all aspects of COVID-19. Now, nothing happened basically, and I think the learning was that we failed to raise to the occasion. We're not ready for the next pandemic. We didn't do any of the stuff that I talked about. And I think we need to realize part of the problem we're in right now, because that bears to all discussions about security and economics and digitalization right now. First of all, I think we live in an age where the complexity is insane. Not only the complexity within the fields, media, security, healthcare research, etc., but also between. And that means that the problems are scaling. So when we move from a paper-based electronic health record to a digital record, you just have problems in all directions at the same time. And we are very, very immature in our solution to that kind of problems today. And that drives into another problem that is actually even worse to some extent. We know in social media there's a lot of radicalization and bad discussions, and the political distrust is growing. And I think we need to deal with the realization that we have to do with what I call relative incompetence. That is, not so much because we are getting more stupid or because we are getting more evil, but we are getting more frustrated. And our relative incompetence, that means that the level of knowledge compared to what we need to solve a problem today is just at a very high level. You get into the situation which you call Dunning-Kruger, where people think they know something about a problem, but really they only scratch the surface. And that means that they can create their relative truth. And that can be very different from other people's truths, and that can create all sorts of clashes. And as you clash, you tend to focus on certain aspects, and that creates what we call radicalization. And we actually see that even within science, unfortunately enough. I mean, you see the anti-crime people that really focus on surveillance and CCTV and stuff like that, because they need to stop everything. We see it in healthcare research, the big data, where they're going totally crazy with their AI. And we see it in media. You basically see it all over the place right now. And I think the best example is actually also what we see in blockchain, where people have this idea that with smart contracts and something like that, they can create these fantastic solutions. But the gap between what we require and what we can do is just huge. And then, of course, this is also driven by greed for power, greed for profit, like in big tech, or simply prestige. I need to do something as a researcher. So actually, our researchers is one of our biggest problems right now. Now, a year ago, I said that I was very much against blockchain and self-sovereign identity for very, very good reasons. But the good thing about this talk is that I actually learned something. We moved because we figured out how to deal with some of the problems, and that's what I'm going to talk to you about. First, let's just illustrate the level of problems we have right now. Take biometrics as an example. This is what I called a digital weapon of mass destruction. Okay, you have both the commercial sector and the government sector creating real problems. First, they do it for control. Well, big tech use it to create control of the consumers. Like when you have Face It on an Apple device, Google or Facebook or TikTok, they do that because if they can ensure that they identify you, then they own you. But governments do the same thing, like Aadhaar in India, with biometrics all over the place. We see social credit that's behavioral based in China. And you actually also see cyber surveillance expanding in Europe with EU entry exit and stuff like that. But these are also turning into attacks where you have biometric targeting like CCTV in store, Google Glass, you have all sorts of cases, and it's going to get a lot worse unless we are stopping it now. And you also see the governments using it for totalitarianism, genocide, like we have in China, where the government is using biometrics and DNA to target the Muslim minority and detect whether they actually are Muslims. You see in Afghanistan, where the US Army means for detecting the friends and enemies in combatants, they were used by the Taliban to detect whether one of the former good guys is actually an enemy of Taliban, and then they're going to get killed. And the stupid thing is, we saw already that happening with ISIS in Iraq after the Iraq war. So we're not learning, okay? The root lesson here, just to pair this small example, is that a biometric genocide database, or a database able to translate biometrics into identity, will always fail. It's inevitable. They get hacked. Even US personnel files got hacked with the most sensitive questionnaires. I mean, you go through the security screening for very, very intense. And that was also hacked and stolen. Now, the really vulnerable part of that database was the biometrics, because if the biometrics is linked to a database, that means you cannot get a new identity. Okay? So the real killer of security today is biometrics. We need to, that's sort of starting with the problem there that we need to deal with. Okay, just an entry example. And right now, these problems are sort of all over the place. We have lots of regulatory packages trying to deal with different aspects of security and identity, GDPR, PSD2, cybersecurity, antitrust, AML, e-privacy, etc. And all of these have sort of conflicting views. And right now, we are actually in a situation where you have eIDAS implementing PKI, public key infrastructure, and GDPR that are inherently in conflict. Okay. PKI is always linkable, always creating personal data, no matter what you do. That's been the lesson until now. And GDPR says data minimization, you should be in control. These two are just clashing at the present situation. And we need to do something about that. So they made eIDAS 2.0, and they create some specific objectives, provide access to secure identity solutions, ensure they can rely on identity across borders, provide citizen control of their personal data, and ensure their security when using digital identity solutions. Wow, that's big words. And then they have something about ensuring competition, open competition in the market. I will get back to this after I talk, because I think it's very clear that this is unclear communication that is not backed by technical substance, but we can do a lot better. Okay, I made this slide to try and get an overview of what is actually the problem with eIDAS 2.0. eIDAS 2.0 is about basically trying to take some what we call ABC credentials, attribute-based credentials, as we know from identity providers, identity mixer, UProof, or in Holland, you know, the IRMA card. And essentially, when eIDAS 1 was made in 2012, 13, 14, starting in 2018, ABC technologies were nowhere near mature enough to build identities, so they weren't included. It's just PKI. And that means that yes, PKI is basically always inherited in a linkable manner, that they're always creating personal data. Now they're trying to incorporate ABC technologies into eIDAS 2.0, and I think that is very recommendable in itself. The problem is that the way they're doing it is that they're applying a standard that doesn't take responsibility of all the issues, thereby ending up basically just trying to build some ABC technologies on top of the problem already in eIDAS. That's not going to work. And some of the example of the problems is that starting with the issuer surveillance, you can only put data into the storage that is already identified. That means that you actually enforce central identification of all data that's going into the digital space. Come on. So we build security through insecurity. Not really a good idea. And that also means that you cannot create a trustworthy basic service because you always has to have control server side. I get back to the point what we mean by that. Now, the next point is the problem that they are creating a digital wallet in a smartphone. Come on, are we going to create the illusion that we can create a secure wallet on a smartphone that's controlled by big tech today? But that's actually what they're saying. That's really a bad idea. Now, then the next point is that we are creating what we call verifiable surveillance, is that we are locking it to a trusted anchor. And that means that we end up in a structure where we perhaps can make limited structure, but we're actually not trying to create trustworthy applications that can be contained in fully. And we know that problem from, for instance, Schrems 2, where you cannot put personal data in a US blockchain because NSA has a backdoor access through legality to access all data in cloud. That's a really bad idea. Now, there are other problems with this structure, and the reason we have the problem, in my view, is that verifiable credentials, as the name of the standard, is basically derived from a standardization of identity mixer, IBM's blinded at use. But that means that blinding at use means that you create a proof that you can reuse again and again and again and again. And that means that you have an inherent problem if that key gets out of control, because they can just continue to sign in as you. So you get a massive revocation problem. That basically means that we need to have mechanisms in place in order to be able to test every time you use a key whether this key has been revoked after it was issued. And that just scales in all directions into serious problems. Not because we in principle couldn't do it. We have mechanisms to stop Sybil attacks. It just doesn't scale. It means basically is that all keys everywhere should always be checked. And how do you ensure what to check against? That is very, very non-operational in that perspective. Another aspect of the problem is that it is failing to what we call the forced assumption that every single proof has to be published or distributed in itself. So I can't create a proof with you that you and me can agree of the semantic content of without having to publish it for everyone to use. That's not really a smart way to do it, because there can be all sorts of problems and it creates all sorts of unflexibility. So what I'm basically saying is that right now we have the problem that eIDAS 2.0 is the problem. You can go back to say it starts with the assumption that you have to identify in order to do anything. You have to identify towards a central database in order to get a proof issued by the issuer. Okay, and that means that we just accumulate personal data. And we basically, I'll get back to that aspect, why that is a problem. And you have the problem that the DID, the distributed identity claims of standard, and the verifiable credentials, they're not really mature enough to make a trustworthy identity in the other end. So it basically ends up creating unsecurity towards unsecurity. At the same time, they're assuming a smartphone wallet that is not under your control. That means that you get the big tech control in below because you don't have access to the ASM module in your smartphone. And you have to push the proofs as what we call you have to separate all the proofs into their single components. So it means that you can make cherry picking. Where a trustworthy identity, that's required that you have consistency across all the proofs, and there's no mechanism to ensure that in Identity ID and verifiable credentials. It's not mature in that perspective. We don't have an identity standard that tells us what is a mature, trustworthy identity. I'll get back to that. So what I'm basically saying is that right now, I get the intentions. We need ABC technologies in there, but the way they're doing it is really bad. Luckily, we can do better. But first, we need to understand what kind of problems we are working with here. Sorry, it just here. In Germany, they're running a number of wallet tests right now, and a good example of how it's not that simple as they think is that only 2 days ago there was an article showing that because the wallet in the smartphone in one of the tests wasn't locked to the hardware, the secure enclave in the smartphone, basically anyone could basically just take the proof and use that because there was basically at runtime no authentication at the low level. You could just create a man in the middle between the user and the proof could just be reused everywhere. And that problem scales all over the place. I mean, think about it. If I can put 100,000 euros on a blockchain account, I can just give you the private key to the blockchain account, and now I can be funding everything, including terror, but there's no transaction because there's been no registration. I just gave you the key to my account. If you do that with Bitcoin and stuff like that, you are all over the place. So my point here is that a wallet is not just about storing reusable keys. That is a really bad approach to it. We need to do a lot better. Okay, so give you an example of why it's not just that. Take here in 2016, Germany said that they were going to join FIDO2. And FIDO, if anybody's aware of it, is these YubiKey things where you have some kind of entity that creates some kind of key that is then fed into the browser, and then in FIDO, that is just locked to the hardware module in the device that's communicating, the smartphone or in the laptop. So that's going to get cross-certified to the device that you're using to go on the internet. Now, FIDO1 was a central shared key with your using that to create some kind of pseudo-random new key. Really bad idea. FIDO2 is great in the sense that FIDO2 assumes that the device is actually creating a new asymmetric key pair for every website you visit. Really cool. And for instance, YubiKey is doing that. The problem is that the first thing they do is locking it to the smartphone. And the smartphone is then identifying you towards the website. So what's the point of creating a new key every time if the big tech control of the smartphone actually instantly take control of the data referability? And they are actually assuming that you can just use the wallet in the smartphone to identify. Yeah, cool. But you're not in control. The big tech data collection is. And it's vulnerable because the security in the smartphone is not good enough. Now, I'm not criticizing what Germany did in 2016 because that was state of the art at that time. In the meantime, something radical has been happening that we've been working for a long time. That is that we now can create FIDO2 keys in a device that has biometric access on the card. And more than that, you can on the card have a display so you can validate in the physical presence that this is actually your card. You're not using someone else's card. And you can see on the card in the tamper-resistant space what it is that you are actually verifying. You can do that in 2016. But now FIDO2 turns into the problem because when you have a secure card creating a new key every time, then big tech in the smartphone is trying to take control of the key in order to link it to the identity in the smartphone that they control. And so the next point here is then that we need to deal with the fact of what is the kind of contextual data sharing we're doing. Right now, in PKI, there's an assumption that you are uniquely identified all the time. That is security. And they are assuming that you start from an identified context, getting some kind of data that you share in another identified context. But that doesn't matter how secure the transfer is, because they can link it in the backend. They got linkable identifiers at that point. That is what we call the big data AI failure. That is big tech, that's big gov. That's not just going to fail. And that is the thinking in a lot of security spaces today. Now, the alternate mechanism is to use the history of data. Yes, we have stored information about us in healthcare systems, and we have in all sorts of databases. But what we need to do is to get them out of the space into a room where we are not identified in the sense that there is a linkable connection between the transaction and other transactions, that you don't give control away. I will continue to show what that is. Because what we are actually aiming for is a setup where we are using data from not identified spaces into new non-identified spaces. So we can share data without conflict. We can access data that is secure at source and use them in a new secure source, and we can do the combination. That's what we call small data. At some situations, we want to take data from a non-identified storage information about us that has been verified in some way, and use that in an identified context. That can happen in a lot of time, but we need to minimize that, because that is actually necessary to have continuity. But we do not want to have spend a lot of time creating trustworthy structures that is then just by someone created into a portal of profiling. So what do we mean by that? We mean, basically, if we take a step back and try to get an overview of the problems right now, okay, we can create a simple quadrant. You have the individual level, you have the community level. You have the security issue, and you have the economic issue. And this problem really starts at the individual security level. If you cannot do anything without identifying, you always lose control. And when you lose control of data, you lose self-determination, because you get a profiled entity, you turn it into a product. And what you're taking there is you're taking away your control of data as a digital price mechanism. Because instead, you are basically being sold every time. You're being profiled, they are translating convenience into controlling you. We need to go the other way around. We need to start by having trustworthy security where we do not create linkability in the transaction in order to have the basis of economics working. Then on the second level, we need to start dealing with the problem of what we can call the ends justify the means effect, where we have said, well, we need to do anti-crime, so therefore we need to do surveillance. No, we don't need to do that. We need to have conditional mechanisms, but they are an exception. They don't mean that we default should be under surveillance in case we do something wrong. We need to go the other way around, and I'll get back to exactly what I mean by that. But we have all the real issues in security for the community level. We have pandemic responses, anti-terror problems, anti-money laundering, all sorts of problems that are real issues that are legitimate interest. And the same thing in economics, where we need to have an effective economy for a society. It's not built on a lot of individuals saying, I don't want to share data. We need to create means so you can share data without losing control, so that we can have learning and research, we can have recycling of products, we can have polluter pays mechanisms where we actually need to go through the value chain. We need to undermine the reuse of data for change instead of having to enter data every time. It's ineffective. So we really need to go back to the understanding that what we are doing right now is that we are doing bad security, that is basically doing bad economics, that is creating vulnerabilities for the criminals, and is doing ineffective economy. So you could call this privacy. I haven't said the word privacy, because to me, privacy is just security for one citizen. And privacy is rarely, in terms of anonymity, the agenda that we want. So let's move on here to understand what it is we're talking about. To have trustworthy identity, you need 5 components. Okay? You need to have at core unique identification. Because if you don't have unique identification, you can create all sorts of identity fraud, identity crimes, all sorts of chaos. is falling from that. But the problem is that we never want to do identification in a transaction. So we need instantly to have a level enabling non-linkability. So we need to be able to create new keys that are non-linkable from any other key for the transaction. And in order to do that properly, we need to be able to, in cyberspace, to be certain that that key is linked to a citizen and only to one citizen. Because otherwise we turn into chaos. And at that point, we have sort of starting with dealing with what we can call trustworthy anonymity. But trustworthy anonymity is rarely the sustainable model in a multi-party transaction. What we need to have is means. If I want to do a contract with you, I need to have means to prove to you that you can identify me conditionally in case I do something wrong. But I need to be certain that you can't identify me until I've done something wrong. This is where we start getting into the issue of trustworthy PKI. So if I can create a new basis on identification, can create a new non-linkable key and prove to you that you could identify me in case I violate the contract, and you are certain that the underlying structure has integrity and consistency, then we have the basis for one transaction. Okay, and then we can customize that transaction with the technical means that is needed for whatever purpose that is. And there can be a lot of stakeholder requirements in there. It could be taxation, it could be cross-border issues, anti-money laundering, all sorts of that. That can be a lot. But what we really need to ensure that we cannot have back doors. What we need to have is open front doors. That is only mechanisms where I create a proof that I can be held accountable if I do something wrong, and I can prove that I haven't done anything wrong, I haven't been stopped. But only until I am actually doing something wrong can this front door, transparent front door, be fed back to who I am. And what do we mean by that? A simple way of doing it is that I can create a proof of non-repudiation that is encrypted to a judge. Okay. I should have showed another slide before that. Sorry about that, but let me illustrate it to you. You have, in one hand, you have a digital signature. You have the card, and it creates a new digital signature. Okay, but the new digital signature is created in the card. Nobody else knows about this. And the card can have a certification key in the card. It already has that. We do that for verifying what kind of device it comes from. This one is just linked to a CA. And what you do then do is a cross certification, a self-incrimination. So you take your digital signature with your name, sign the public key of the new key, and you take the private key of the new anonymous key and sign the old digital signature. What you're basically saying is that the real me signs self-incrimination. I created this, and the new me created that this is the owner of me. You need a cross certification, and you then encrypt that as a self-incrimination proof, and you encrypt it in such a way that in order to open it, you have to go through a transparency process. And if you do it wisely, you do it so that the decryption keys will die by itself over time. That's what we call graceful degradation. But in principle, all I need to do is to have a CA, a judge with a public key. I get a digital signature from my national identity CA, put it in the card, create a new key, cross-certifying the card, then encrypt it to the judge, to a judge, and then I can basically show that proof, saying, well, look, there's non-repudiation in this, but only if the judge determines the necessity of verifying it. You can verify that this is accountable because the card, I cannot change the card, it's tamper resistant. So the card actually acts as a witness between us. Now, the point is that this issue about customization can have a lot of different aspects, which I don't have time to go into. But we can create exceptionally advanced negative proofs. I'm not wanted, I'm not searched for, I'm unemployed, I'm not unemployed, etc. That is part of the customization. That depends on the actual context, the application. But there is a more general problem. That is, conditional accountability is the issue of going from the pseudonymous, trustworthy signature to who I am, in case I do something wrong. The problem is that a lot of the really hardcore crimes is not consisting of a lot of criminal activities. They are consisting of activities that together are criminal. And that goes the other way around. That means that the government says and the police says, and that's actually true, that in case we know that you are involved in something criminal and we want to figure out who you're talking to, we need linkability. But that's actually the same problem, just reversed. It means that whenever I create a key, I can create a proof that is encrypted to say that, okay, I created all these keys. I'm not going to tell you what these keys are doing, but you have a way to figure out. What we then, as a society, a democratic society, need to do is to contain that in time and extension, so that you can only have the last 14 days of linkability, if that's what needed, or in case that I am convicted and investigated as a potential criminal, all new keys. And I'm saying, yes, this is insanely dangerous. Potentially, if the Chinese government had that kind of mechanism to override everything without transparency, then you have the worst nightmare. But that is reality of security. So we need to realize that in order to have trustworthiness, we need to have both unique identification and strong non-linkability anonymization. And we're talking better than Tor. We need to have conditional accountability, because we cannot prove everything up front. We cannot eliminate all security in a transaction. There needs to be some kind of mechanism so we can engage in a contract where I, for instance, get credit or things that we cannot design out of the first place. And then, for instance, government will say, well, we can need to have conditional linkability according to the regulation in that country. These issues all need to be in place. And the hard problem is that it's very easy to make these bad, what we can call unreliable, that can be broken, just as we saw with the German SSI wallet the other day. We could also create some kind of surveillance structure that claim to do this with some kind of trusted parties, so that when you have a public key cryptography, you can create a certificate where the CA entity doesn't include your name in the certificate, but they know who you are. That's just trusted. That means that you have backdoor to everything. Now, to do trustworthy, that requires you have integrity all the way around. That's hard. We haven't done it. That's what we are doing now. Okay. So why are we here as we are now? Give you an idea of what we come from. Citizenkey is originally started as a project in 2004, and with the agenda to start a model of security models. Okay, and our three primary objectives has to be trustworthy, has to be inclusive, all types of transactions, and has to create interoperability between all types of transactions. That's the level of ambition. We also say that we need to have what we call asymmetric asynchronous upgrade. Okay, we don't want a fact problem where we introduce a new technology and everybody has to use it before I can use it. So that nothing changed by that. I need to be able to introduce a new technology and start using it because it's a benefit of me, and you will start using it because it's a benefit of you, and then we get a positive reinforcement as the take-up encourages. That means you need to have backwards compatibility. Okay, it's not about making everything perfectly secure and then magically hope that we just transform to this kind of technology. We need mechanisms that can link back to the existing structures, incorporate data from that place into the new room. And in the new room, then we can just create what we call forward compatibility. That means new standards that we didn't necessarily even imagine when the structure was made can be incorporated. And a good example here is self-sovereign identity or verifiable credentials, because that is a new standard that was created long after Citizenkey was started, and what we're just building a structure where that can be added. And why can we do that? We can do that because when Citizenkey, the project was originally started, The agenda was to establish or enable what we can call semantic trustworthy identity, the most complex, more detail-grained identity parameterization we can do, and to build that in ABC as attribute-based credentials, and particularly in blinding and issuance. I get back to why blinding and issuance. Where we use that as the internal model, which we can then at runtime customize to existing standards that will be of lower granularity. Now, that was where the project started. Now, the reason we talk now is because we realized that we can and need to basically deploy a much faster model, because we can use a card as a witness. Okay, so we can create what we call artificial blinding. Artificial blinding means that since we, instead of having a central CA that knows the linkage between the root key and every new key I make, you can have that in the card, and the card doesn't reveal that information, but in a tamper-resistant mechanism that I cannot change, so you can rely on it. Okay, so what we can do is that we can use the card to create what we call a trustworthy PKI, trustworthy key that can be accountable, that can be linkable according to regulation, but nobody knows upfront who this is. And then we can use a simple XML structure that we can verify in the card to exchange data. That means that we can use that as a platform for more advanced cryptography like self-sovereign identity or ABC blinding. Okay? I'll show you how that works. This is the basic Citizenkey model. You create a new key every time. And for every that key, you need to be able to sign. You need to have an individual trustworthy PKI signature. You need to be able to communicate. You can do that when you have a asymmetric key. Share and reuse data, proof credentials. I said this last year, so I'm not going to continue doing that. But the root point is that you can do that and maintaining non-linkability between the keys. That's the core. If you don't have that, you don't have any security, because then control transfers to someone else. Now, that means that this is a little bit advanced, but let me illustrate that each of these identities can then be customized to that specific standard. So this one could be OpenID. This one could be a blockchain DLT account, and all of that. But you could also create, and here we have an example where I have a telemedicine case where I have a device that is basically doing heart monitoring. Now, if we do that at home with telemedicine, it would be a surveillance model, creating sensitive personal data every time you do it. But if every time this device gets to go on the internet from home, you create a new signature, new identity, and the device is locked to that new identity, and you just create a measurement for this transaction only. And then the next transaction will create a new key, a new key, a new key, a new key. Okay? So what will happen is that you have an intelligence structure where you in the structure are able to create proofs later on that, well, this was the trend of my heart rate over a long period of time. And you can maintain trustworthy anonymity because there's no need for accountability when you are, because you're not doing any transaction. What you need to have is another kind of mechanism that is customized to this. That is a mechanism to have an alarm. So I need to be able to deposit some kind of mechanism that for 24 hours can be open to my address. So in case something goes wrong, an alarm goes, you need to be able to open it and figure out who I am. 24 hours, that needs to die. So you can't do it anymore. But otherwise, all the data you create can be what we call trustworthy anonymous. We know that this is linked to one and only one citizen. And I can even have the structure where I can start with a consultation with my doctor. He creates a diagnosis. I have a proof of diagnosis. I have a heart rate condition of this type. And we can use the card and the mechanism to introduce that into the trustworthy anonymous space. Okay, so you can have in the bottom, you can use trustworthy PKI and simple XML structures. You can then translate it into the specific standard you're using for whatever you're doing, so that they have semantic knowledge about the owner without knowing who the owner is. And then the device can do what the device does. It creates heart measurements. So it means that somewhere in cyberspace, there is a patient that is monitored for heart failures constantly. And we have a mechanism to save him in case something goes wrong, and we have the mechanism to do analysis across, but we don't create personal data. And then, because this is not locked to self-sovereign identity or the specific cryptography, but it's locked, but that's just a container within the identity structure, I can take the data from that space and reuse that together with the data from my doctor to create new data, for instance, for trustworthy anonymous research. So in principle, there's no reason why we have this big data problem where doctors think that they need to have central surveillance and central combination of data and then some kind of pseudo anonymization afterwards in order to do research, because I can give you exactly what you want in the trustworthy anonymous space. You see the point? So what we are actually saying here, as a generic example, is that a self-sovereign identity wallet, or what they call an EU wallet that they're trying to build on the smartphone, should be changed and can be changed in such a way that we pull the keys into the tamper-resistant devices so the big tech don't get access to them. And we can create a dedicated virtual wallet for that SSI context. So that even if you create keys that can be reused within the context, they cannot be, if I lose control of it, if they're stolen for somehow, it's not a problem because they cannot prove anything about me. They can only prove something about this context. That means fundamentally that you create what we call trustworthy inclusive interoperability, because any standard can be applied through creating a new trustworthy key and applying that standard on top of that, and then moving data across the structure. We just need the intelligence to manage it. Okay. An interesting part for those that are interested, we were involved in a big project together with Hydra back in 2006 to 2009, with Fraunhofer, called Hydra, that was doing linking all interactive IoT devices with all other IoT devices. And this was the missing link. We didn't have the identity, the security solution to create it. We can easily create the semantic integration so that one device can pull resources from another device. That's easy. But to do it secure, we couldn't do that in those days. So we gave up. This is only 12 years ago. Today, we could solve that problem simply by incorporating trustworthy PKI at a level where you can control it. Okay. So what does it mean? What is Citizenkey? Citizenkey work with what we call 5-factor security. Okay? 5-factor security means that in the actual card, you work with the 3 factors, something you are, the biometrics, you have biometrics collection on the card. Something you have a tamper-resistant device that has keys in there that you cannot prove anything unless you have the access to the card and can open it. And something you need to have some kind of PIN or proof in order to open the card. That's just temporary because it is to delay in case it's stolen. But you need all 3 of them actually to have security, not just 2 of them. And the 4th factor is what we call trustworthy PKI. Okay, I need to be able to, for the device to be able to create a new representation of itself, creates a new key, and it never leaks an identifier again. Because then that would scale up in the digital value chain. Let me repeat that. The card is designed in such a way that it will, for every purpose, create a new asymmetric key pair and change all external identifiers accordingly. So you should not, in principle, be able to see on 2 transactions whether they originate in the same card on 2 different cards. That's the ultimate test. Okay. Now, you then have the problem of long-term communication and usability. And you can do that in the mobile phones, for instance. And the hard problem is not about doing that. The hard part is ensuring that the big tech running the mobile phone doesn't get access to knowledge about the context, the device. They shouldn't be able to link the new proof to the device ID of the mobile phone, because that would be a security contamination. Okay? So the main purpose of the app on the smartphone is basically to extend the key control in your device up to the net, to the point so that you can create 2 sessions on the internet that are inherently non-linkable. But each of these can have a trustworthy digital signature that makes you accountable, non-reputable, and linkable in any other way, except for one thing: you are not identified in both contexts in such a way that they can determine that this is the same citizen, unless you explicitly share some data that do that. And if you want to do that, for instance, if this session is a linkage to your doctor, you can always take that proof and encrypt it to your doctor. So your doctor can know that this session is you, but the system doesn't need to know. So the system, so what we get is a structure that can solve the Schrems 2 problem. I can actually sign and share data in cloud without creating personal data in the security sense, but they could be made into personal data if a judge opened up because I did something wrong. Okay? And such a structure would be what we call a trustworthy anchor for SSI. And that means that we create a wallet structure that has a hardware wallet in the bottom and has a virtual software wallet for each container, so that we can contain the risk within that space. And then we can use the underlying structure to exchange data between standards. So we're not locked to one standard. We can have open exchange. So what we built is basically, well, you can, if you want to, consider it a virtual blockchain for each citizen. But it doesn't exist, this blockchain, because it's just logically linked. It's not a physical structure anywhere except for you, because in principle, you should be the only one able to establish this. And it also means that I can query into your, let's call it, identity chain, if and only if you want to create the linkage. Okay, so you can have access to your entire history. You can have all the convenience you want, but the counterparty can make requirements so you cannot lie. You cannot claim that you are not convicted for a crime. If you are, for instance, you should be able to avoid that. But as long as it's just about operating through your daily life, you should be able to create a new key for every purpose, share the data needed to customize the transaction, have strong security so that criminals are not going to get anywhere near this, and get the service without creating personal data at all. That's what we call a trustworthy, sustainable, small data space. It's a lot more advanced when you go into the work relations, when you go into healthcare, when you go into anti-money laundering, if you go into all these kind of spaces, but they are contextual specific. That is beyond what we're talking about here. I said this already, so that the point is that each different identity can have a different context, but that doesn't mean that they all have to be non-identified. So I can take a traditional digital signature and use that to access my bank. But I can transfer information from that context and money, that's sake, into a new context, non-linkable, and with interoperability. And part of that is also that you have a structure where the card basically compensate for the lack of security in the smartphone, because you create a communication channel in the card that the big tech cannot control. I talked about that last year when I talked about solving the COVID-19 infection trace, and we can do that in the actual card. So we can create new anonymous mechanisms to do contagion dation or trace without relying on Google and Apple's control of the Bluetooth device in the smartphone. A lot more to say about this. Let's skip that. We don't have time. So the overall structure actually means that we can create mechanisms so that I can create a new key, I can put it into cyberspace, I can interact with another entity, that could be a company, and behind that entity, I could know the company, but I don't need to know the citizen, that the employee. I doesn't need to necessarily need to know the employee. And without creating personal data in this this space, if we then decide to put that in a blockchain, it doesn't matter because it's trustworthy, secure already before we get to the blockchain stage. So it's not about GDPR, because you got isolation, data minimization by design, because you want security, not because you want privacy. It's better than that. And also means that in this space, you have a full legitimate identity where all other legitimate interest stakeholders can actually require proofs from you in order to justify the transaction can continue and finalize. So my bank, if I try to spend money from my bank account, can know that one of the bank's customers are trying to do a payment online. And that means that they have a requirement to both validate, know your customer, that I'm actually doing a transaction that is conformant with the information I've given you. I belong to the group of people that are allowed to do business to consumer shopping. And then the bank can turn around and say, okay, my side, my customer side of this is okay. And I can now start dealing with the question of who am I paying? And if I'm paying a normal shop with an invoice and there's been taxed, etc., then there's no problem. Then the money can just be released. And you have not created surveillance, even if you do anti-money laundering. That's sort of a vital aspect, very advanced structure. And whether you decide to put that in a trustworthy ledger, it's okay, doesn't matter, because it's isolated from any other transactions. So get back to the eIDAS structure there. I think that the formal claims that they make, I don't understand them. They're just bureaucratic nonsense in my view. And certainly they do not provide citizens with control of their personal data, nor do they ensure their security, nor do they create interoperability, nor do they create structures that works, because they actually require everybody to run the same crypto. A standard is compliant or interoperable with the same standard is not interoperable. You need to have something that is inclusive, interoperable between everything. That's not what they're making. But what they're actually trying to do, and there's some justification in that, they're trying to provide citizens with means to control data sharing. They just use verifiable credentials in a way that doesn't work. The intention is okay. They try to prevent big tech from taking control of citizen wallets using some kind of member state wallet. The intention is okay, but the means doesn't work because they put it in smartphones and it's too simple a structure. They try to establish interoperability between identity service providers, but they try to do it through enforced standardization. But fact is that the way the structure works is that you need to create what you call a link secret, and that cannot be shared between providers. It doesn't work like that. And in the end, there is a fourth agenda, which actually is a real need, is that we need to provide means for long-term reliance on contracts. Right now, you're in a situation where if you and me create a contract that has to last for 50 years, 100 years, in the meantime, for instance, quantum computers or something else could break the kind of math that we use. For example, if we can create a collision on a SHA-256 hash, then in 50 years, a contract today for me to buy my house is created with a hash of the contract, and then I signed it. And then in 50 years, if they can create a new contract with another kind of content with the same fingerprint, the same hash fingerprint, they would be able to claim that this new contract, for instance, with a claim that I have to sell my house for 400 euros in 50 years is the new contract, and I signed that 50 years before because the hash value is the same. And Today you can't do it because you cannot create a new document with the same hash value. But in principle, there's an endless number of documents that has the same SHA-256 hash value. So this is extremely vulnerable. The security today is extremely vulnerable to the new kinds of breaking the math behind it. But, and here comes the point, ledger technologies make sense in the sense that you cannot just rely on a ledger that's not secure enough, but you can perhaps, through combining a number of different mechanisms like different hash chains, create a situation where weaker protections together require a much stronger attack than just breaking a SHA-256. Okay, you get what you call a Cartesian product of defense. So it could be that I could create a contract that breach one technology, but if there are 2, 3, or 4, or 5 technologies applied at the same time, I can actually create mechanisms that, even though doesn't have the quantum secure mechanisms today, perhaps they could be protectable in a long enough time frame for us to get new mechanisms. We can then recertify the old contracts and thereby prevent this kind of attack. And that is purely justifiable, that the application of ledger technologies for that. But the root conclusion of what I'm trying to say here is that none of these mechanisms are really achieved with the present proposal. But we can solve that problem, both in eIDAS, in distributed ledger technologies, and self-sovereign identity, by going upstream and solving the security problem in the PKI security problem in eIDAS. We can eliminate the linkability in eIDAS, use that as an anchor for new transactions. And if we do that, it's not a problem that you store data in a blockchain. It's not a problem if there is some system problem with the structure that means that you assume that you have to identify, because the identification is locked to the context. I hope that makes sense. I will skip this because I think you've got too much at this point, but this is about how we make it code-free. So what we are doing right now, just to finalize it, is that we are creating a proof of concept for blockchain called Trustworthy DLT, where we are taking anti-money laundering, GDPR, and cybersecurity, the theft of keys, and solving all three of them in the same structure as a trustworthy intermediary that helps providers get access to blockchain. It has to be code-free integration, it has to be inclusively interoperable. That means that we don't care about which blockchain it's working in, and it has to be trustworthy secure. That means that there's no man in the middle that collects information about anything. But you still are able to validate the transaction before it gets into the blockchain and the money is in the hands of the terrorist, as an example. But it also means, and that is really important for banks, that you can prove all the transactions related to an account. So you can prove the provenance of money even in a blockchain. Today you can't do that, so therefore banks don't want money from a blockchain because they are most probably some scheme that's linked to money laundering. Okay, I think that was what I had to say.